Hi, today we are going to start looking at fractals. So first we'll talk about what a fractal is. So a fractal is an infinitely complex mathematical shape. Typically, it will have a repeating pattern to it. Now we'll also look at ones that do not have repeating patterns. These are referred to as fractured curves, which is a real world shape that cannot be described as a polygon since they're irregular in shape, so it can't be described as a rectangle or a trapezoid. Example of this would, for example, be a country's coastline. Now, to try and measure fractured curves, we typically simplify the shape with many straight lines. So we'll do an example of this coming up. So when you know what the distance of the coastline of this image of Antarctica would be if we measure of 2 centimeter increments as well as 1 centimeter increments. So I'll do these in different colors so it's easier to see. So we'll start by doing our 2 centimeter increments in blue. So I'm going to grab a ruler and just mark out, start in one place and work my way around, only drawing lines that are 2 centimeters long that go from one part of the map to another edge of the map. So you'll see we can't, when we're only measuring the 2 centimeter long segments, we're not getting stuff super close to coastline, but we're approximating the shape to some degree. Now we'll go around and count how many line segments we had, and then multiply by 2 to get our distance in centimeters. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we've got 20 times 2 centimeters. So we get the distance around, or circumference, is 40 centimeters. Now, we'll do the same thing, but we're going to shorten it up to increments of 1 centimeter. So I'm going to start in the same spot as before, but we're only going to do 1 centimeter increments. Okay, so we drew that in. This time as I went around, I counted how many we did in my head. Essentially, we did 43 segments. So we did 43 segments that were each 1 centimeter long. So we got 43 centimeters. Now, these are not the same values. So what you'll notice is our green lines followed our coastline a lot closer. And as a result, we got what's probably a more accurate measurement. And we ended up with a larger number. Now, as we decrease these increments more, we would probably end up with a larger distance and a more accurate measurement of the actual coastline. Now that we've looked at that, we will look at some common fractals, which are shapes that have repeating patterns. So we're going to look at the Koch snowflake and the Sierpinski gasket. Now, the Koch snowflake is a snowflake that's created by continually modifying a triangle by adding smaller triangles to it. So to create a Koch snowflake, we're going to draw an equilateral triangle. We'll then split each side into 3 equal length line segments and use the middle line segments to create smaller triangles. We'll then repeat 2 and 3 indefinitely with any of the line segments. So I'll show this on the next page. So I already have where the corners of this equilateral triangle are. So I will start at stage 1, then every stage I'll change what color we're using so we can see what's happened in each stage. So we have our starting equilateral triangle. And then we'll go into our first stage of our Koch snowflake. So if we go back, we're going to split each side into 3 equal length line segments. So I'm going to just change up what color I'm using. Okay, so first we need to know how long this is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27. So it's got 27 dots. So splitting that into 3 gives us 9 dots per segment. So I'm going to mark that on each of these sides. So we've now split this into 3 equal segments. We'll do that with this and this. Okay, now if you go back, we're going to use these middle segments to actually create more triangles. So we have this segment here that we're going to change into another triangle. So we're going to build a triangle off of this segment. So we're going to draw that out. I realize I did that slightly too far to get our equilateral triangle. But we now have the equilateral triangle. Each side length of this is 9. So we'll do that with each side. Now, unfortunately, at the bottom, we're going to run out of space, so we won't be able to repeat the pattern nearly as much on it. Now, once we have this done, what we're going to do is go back and erase the line segment where we drew the new equilateral triangles. So this is stage 1 of the Coke snowflake. Second stage, we do the exact same thing, except for we are now going to take each of these straight lines and break it up into 3 separate parts. So we know these are 9, so therefore breaking them into 3 parts would be groups of 3 dots. And we're essentially going to do the same thing as we did in the last stage. So these middle segments will then draw equilateral triangles off of. We'll then go back and once again erase inside lines. And this is essentially our stage 2 of our snowflake. Now I'm not going to do it today, but we can essentially continue this process indefinitely. So we'll just go back and continue taking any straight line, breaking it into 3 sections, and draw new equilateral triangles. But essentially, this is what it looks like after the first 2 stages. Okay, next we're going to look at what's known as a Sierpinski gasket. It also starts with an equilateral triangle. This time, instead of modifying what's outside the triangle, we modify what's inside the triangle. Now to create, we draw an equilateral triangle and split each side into 2 equal segments. We then join these midpoints of straight lines, which turns the triangle into 4 smaller triangles. We remove the center triangle, and then we repeat steps 2 to 4 indefinitely. So this one, I will, just like the last one, break it up step by step. So first one, we find the midpoint. So in this case, the midpoint would be 8. So midpoint there, and midpoint here. We're then going to join those points together. creating four triangles. The next step is we essentially get rid of the middle section. So that's usually shown by just shading in what's gone with black. I'll just widen this to make it a bit quicker. You can always touch up the corners later. So this is essentially our first stage of the Sierpinski gasket. Our next stage, we just repeat this process over again. So split each of these triangles sides in half and join them with a ruler. And then once again, we will shade in the centers because they are being eliminated. So this is our first two stages of our Sierpinski gasket. I think I might do one more. If I do one more, I'll once again break all sides in half. Join those points. And then our next step at this stage is once again shade them in. And we've done essentially 3 stages of the Sierpinski gasket.